Welcome to AWS Mastery Labs, turning AWS chaos into clarity with bite-sized tutorials, hands-on labs, and exam-smashing tips. In this video, we'll walk you through the core building blocks of identity and access management, what IAM is, why it's critical for your cloud security, and how to start using it the right way. Whether you're new to AWS or an experienced developer revisiting the fundamentals, this session will help you build a strong understanding of IAM. We'll unpack essential concepts like users, roles, policies, and permissions, and explore how IAM plays a central role in securing your AWS environment. Let's get started. AWS Identity and Access Management, or IAM, is a core AWS service that lets you securely control access to your AWS resources. At its core, IAM helps answer two fundamental questions: who is authenticated, and who is authorized to do what? It acts as the security gatekeeper of your AWS environment, ensuring that only the right identities, whether they're users, applications, or services, can access specific resources. IAM enables you to define, enforce, and audit access policies at a very granular level, making it an essential tool for maintaining least privilege and compliance in the cloud. IAM gives you fine-grained control over permissions through users, groups, roles, and policies, using a JSON-based policy language that acts like a rule builder. This means you can define exactly which actions are allowed, under what conditions, and for which resources. It also supports federated access, letting you integrate with your existing identity systems like AWS SSO, Active Directory, or third-party identity providers using SAML or OIDC, so your users can sign in using credentials they already have. To strengthen your security posture, IAM also supports multi-factor authentication, MFA, adding an extra layer of protection beyond just usernames and passwords. With IAM, you're not just managing access, you're laying the foundation for secure, scalable, and compliant cloud architecture. When you first create an AWS account, you're given a single, all-powerful sign-in identity, known as the root user. This root user has unrestricted access to all AWS services and resources in the account. It's essentially the account owner and should be treated with extreme care. To protect this identity, it's critical to enable multi-factor authentication, MFA, as a first step. Think of it as adding a security vault around your account's master key. Because of its power, best practice is to safeguard your root user credentials and use them only for specific tasks that absolutely require it, such as setting up billing information or modifying account-wide settings. For all other activities, even administrative ones, you should create IAM users with admin-level privileges. These users can handle elevated operations while still being subject to the same fine-grained access controls as any other identity. For everyday tasks, stick to IAM users and manage their access using IAM policies to grant permissions to specific resources. And when you need to allow secure temporary access to services or resources, for example between applications or accounts, use IAM roles for secure delegation. In essence, treat your root user like your cloud's crypto wallet. Protect it, lock it down, and only bring it out when absolutely necessary. In AWS, IAM users represent individual identities, like developers, admins, or system operators who need access to the AWS environment. Each user has their own set of credentials, such as a username and password for the console, and access keys for programmatic access via the CLI or SDKs. These users can be assigned specific permissions through IAM policies, allowing precise control over what each person can do. To simplify management, AWS also allows you to organize users into IAM groups. A group is simply a collection of users that share the same set of permissions. Rather than assigning policies to individual users one by one, you apply them to the group, and all users in that group automatically inherit those permissions. For example, you might create common groups like admins, developers, or read-only users, each with a defined set of policies tailored to their responsibilities. A critical best practice when working with users and groups is to follow the principle of least privilege. That means only granting the minimum permissions necessary to perform the required tasks. This approach helps reduce the risk of accidental or unauthorized access and strengthens your overall security posture. Let's take a look at how IAM groups, users, and policies interact in a typical AWS environment using a real-world example. In this setup, we have three IAM groups, one for developers, one for the compliance team, and one for business operations. Each group has its own set of IAM policies that define what members of the group can access and do within AWS. Now let's consider two users. The development lead, who is a member of both the developers and compliance groups, and the operations lead, who is part of both the business operations and compliance groups. Because users in IAM inherit all permissions from all groups they belong to, both leads will be able to perform a combined set of actions from all the policies assigned to their respective groups. For example, the development lead gets both developer permissions and compliance level oversight, enabling them to work effectively across both domains. Additionally, we have an independent IAM user named controller. This user doesn't belong to any group but has inline policies to directly attach to their identity. This means their permissions are defined individually, giving administrators precise control over what this user can do without relying on group-based inheritance. This example illustrates how IAM enables flexible and composable access control, where permissions can be tailored through a mix of group-based policies and individual configurations, while still aligning with the principle of least privilege. IAM permissions define exactly what actions a user, group, or role can perform on AWS resources. These permissions are controlled through IAM policies, which are written in JSON format. Each policy specifies allowed or denied actions, resources, and optional conditions. There are three main types of IAM policies. AWS managed policies are predefined by AWS and designed to cover common use cases, making them a great starting point. Customer managed policies are created and maintained by you. These offer greater flexibility and control for custom access requirements. Inline policies are directly embedded into a specific user, group, or role. While powerful, they're best used sparingly and for tightly scoped, one-off use cases. Regardless of the type, always follow the principle of least privilege. Grant only the permissions that are absolutely necessary for someone to perform their job. This minimizes security risks and ensures tighter control over your cloud environment. IAM policies are written in JSON and follow a specific structure that defines how permissions are granted or denied. Let's break down the key elements that make up an IAM policy. Version specifies the policy language version. For most policies today, this is set to 2012-10-17. ID is an optional identifier you can use to label or track the policy. Statement is the heart of the policy, and every policy must include at least one. Each statement defines a single permission rule. Within each statement, there are several components. Seat statement ID is optional and helps identify or describe individual statements. Effect determines whether the rule will allow or deny the specified actions. Principal defines who the policy applies to, typically used in resource-based policies. Action lists the AWS service actions, such as get object on an S3 bucket or start instance for EC2, that are being allowed or denied. Resource specifies the ARN of the AWS resource to which the actions apply. Condition is optional and lets you apply logic to limit when the policy is in effect. For example, only allowing access from a certain IP address or during specific times. Understanding this structure is key to writing secure and effective IAM policies, and it's where the real power of IAM comes into play. When we talk about inheritance in the context of IAM, it's important to clarify that IAM policies do not follow inheritance in the traditional object-oriented programming (OOP) sense. There are no parent-child relationships where permissions cascade down automatically. Instead, IAM policies are aggregated, meaning that all policies attached to a user, group, or role are combined during policy evaluation. When an IAM user has policies from multiple sources, for example, directly attached user policies, group policies, and potentially session policies, AWS evaluates the union of all allow statements. If multiple policies allow access to a resource, those permissions are combined, enabling the actions across the resources specified. However, there's one critical rule that always applies. An explicit deny always wins. If any policy, regardless of its source, contains a deny for a particular action or resource, that deny takes precedence and access will be blocked, even if other policies allow it. Another common scenario involves roles. When a user assumes a role, they do not carry over their original permissions. Instead, the permissions for the session are entirely determined by the policies attached to the assumed role, and any session policies that might have been passed during the assumption. This is a hard boundary. You don't inherit anything from the caller's identity. In the case of service-linked roles, inheritance is even more restricted. These roles are created and managed by AWS services to perform tasks on your behalf. Their policies are tightly scoped and predefined, and they do not inherit or accept any policies from user or group identities. Finally, at the organizational level, service control policies, SCPs, act as top-down permission filters. They define the maximum available permissions for accounts within AWS organizations. So even if a user or group appears to inherit broad permissions within an account, an SCP can effectively override or restrict those permissions by preventing certain actions altogether. Password policies in AWS IAM are an essential part of securing user access. They define a set of rules that enforce security standards for IAM user passwords, helping you maintain strong authentication practices across your AWS environment. Some of the key password policy settings include setting a minimum password length, typically between 8 to 14 characters, to prevent weak passwords, requiring the use of uppercase and lowercase letters, numbers, and special characters, ensuring complexity and making passwords harder to guess or crack. Enabling password expiration, such as forcing users to change their password every 90 days, helps reduce the risk of compromised credentials being used over time. To prevent users from cycling through the same passwords, AWS allows you to prevent password reuse by keeping a history of previously used passwords. You can also require a password reset on first login for new IAM users, helping ensure that credentials are unique and known only to the user. While strong passwords are a good first step, pairing them with multi-factor authentication, MFA, adds another critical layer of security, ensuring that even if a password is compromised, unauthorized access is still blocked. Remember, password policies and security settings can and should be tailored to your organization's specific compliance and security needs. AWS gives you the tools. It's up to you to enable and enforce them properly. Multi-factor authentication, or MFA, is one of the most important steps you can take to secure your AWS environment. It adds an extra layer of protection beyond just a username and password, making it significantly harder for attackers to gain unauthorized access. Here's why MFA is critical in AWS IAM. Enhanced security. MFA requires a second factor, like a mobile app or hardware token, in addition to your password. This significantly reduces the risk from stolen credentials or weak passwords. Protection against phishing and credential theft. Even if a password is compromised through phishing or a brute force attack, MFA prevents unauthorized access. It acts as a final barrier that attackers typically can't bypass. Securing the root account and IAM users. Your AWS root account has unrestricted access, and securing it with MFA is absolutely essential. Similarly, IAM users with elevated privileges should always be protected by MFA to block malicious actions. Compliance and best practices. MFA is a requirement for many compliance standards like CIS benchmarks, SOC C2, ISO 20001, and PCI DSS. It's also a key recommendation in the AWS well-architected framework under the security pillar. Avoiding costly security breaches. A single compromised account can lead to serious consequences, from data loss to financial damage. MFA helps prevent misuse of services, including attacks like cryptojacking, where your resources are hijacked for mining cryptocurrency. Flexible authentication options. AWS supports a variety of MFA methods, including virtual MFA apps, hardware tokens, and FIDO-compatible security keys, giving users the flexibility to choose the best fit for their environment. Enabling MFA is a simple, powerful, and cost-effective way to greatly improve your AWS security posture, and it's a step every organization should take immediately. One of the most common and convenient ways to implement MFA in AWS is by using a virtual MFA device. This method leverages mobile apps like Google Authenticator, Authy, or the AWS MFA app to generate a 6-digit time-based one-time password, or TOTP. Each code is valid for just a short window of time, adding a secure and dynamic layer of protection that goes far beyond a static password. Virtual MFA is both cost-effective and incredibly easy to set up. All you need is a smartphone and a few minutes to link your IAM user or root account to the app. Once configured, you simply enter the generated code at login, adding strong, practical security with minimal overhead. It's a quick win for securing your AWS environment and a highly recommended best practice for all users, especially those with elevated permissions. A hardware MFA device is a physical security token that generates a time-based one-time password, just like a virtual MFA app, but in a dedicated piece of hardware. These devices are especially useful in environments where mobile devices aren't allowed or where strict compliance requirements call for physical authentication methods. AWS supports models such as Gemalto and SurePass ID tokens, which are specifically designed for integration with IAM. While hardware tokens are typically more secure, since they're not susceptible to mobile malware or SIM-based attacks, they do require an upfront investment, as each user needs their own device. That said, for high-value accounts, administrative users, or regulated industries, hardware MFA offers a robust and tamper-resistant layer of protection that goes the extra mile for security. Another powerful option for multi-factor authentication in AWS is the use of FIDO security keys, which support FIDO2 and WebAuthn standards. These are physical devices like YubiKey or Titan Security Key, designed specifically for modern, passwordless, and phishing-resistant authentication. FIDO keys use hardware-backed cryptographic protocols to authenticate users and can connect via USB, NFC, or Bluetooth, depending on the model, making them both flexible and user-friendly across different devices. What sets FIDO security keys apart is their ability to prevent phishing attacks entirely. Since they cryptographically verify the origin of the authentication request, attackers can't trick users into entering credentials on fake login pages. This makes FIDO keys an excellent choice for securing high-privilege accounts, especially in environments where maximum protection and regulatory compliance are key priorities. Multi-factor authentication is not optional, it's essential. Irrespective of the deployment option, it protects against common threats like phishing, brute force attacks, and credential theft, and is often the last line of defense between your cloud resources and a potential breach. By enabling MFA, you're taking a proactive step toward resilience, accountability, and long-term cloud security. When it comes to programmatic access to AWS, access keys play a central role. While the AWS Management Console uses a username, password, and MFA for access, tools like the AWS CLI and SDKs rely on access keys for authentication. Access keys consist of two parts: the access key ID, which acts like a username and follows a predefined format; the secret access key, which is essentially the password, a long, complex alphanumeric string that must be kept private. You can create, deactivate, or delete these keys through the AWS console or CLI, and it's critical to handle them securely. Best practices include storing access keys in AWS Secrets Manager or other secure credential stores, rotating keys regularly to minimize risk in case of exposure, avoid hard-coding them in scripts or committing them to source control, a common and dangerous mistake. Ultimately, access keys provide the bridge for automation and application-level access to AWS, but they must be managed with care to keep the environment secure. An IAM role is an IAM identity that you can create in your account that has specific permissions. An IAM role is similar to an IAM user in that it is an AWS identity with permission policies that determine what the identity can and cannot do in AWS. However, instead of being uniquely associated with one person, a role is intended to be assumable by anyone who needs it. Also, a role does not have standard long-term credentials, such as a password or access keys associated with it. Instead, when you assume a role, it provides you with temporary security credentials for your role session. You can use roles to delegate access to users, applications, or services that don't normally have access to your AWS resources. For example, you might want to grant users in your AWS account access to resources they don't usually have, or grant users in one AWS account access to resources in another account. An AWS service role is an IAM role that you create and manage, allowing an AWS service to assume the role and perform actions on your behalf. These roles are useful when a service, such as EC2 or Lambda, needs permission to interact with other AWS resources like S3, DynamoDB, or SNS. The permissions for a service role are defined through policies that you attach to it, and you have full control over its permissions and trust relationships. For example, you might create a service role that allows an EC2 instance to access an S3 bucket for storing logs. An AWS service-linked role, on the other hand, is a special type of IAM role that is automatically created and managed by AWS for specific services. These roles are tightly integrated with AWS services and cannot be manually modified or deleted unless the associated service is disabled. Service-linked roles simplify permissions management because AWS defines and updates their policies as needed. For instance, the AWS service role for EC2 Spot role is automatically created when you use EC2 Spot instances, enabling AWS to manage the service on your behalf. As your AWS environment grows, so does the complexity of managing and securing access. The IAM security tools give you deeper visibility into who has access to what, allow you to simulate and test permissions before deploying, and help you maintain a secure and least privilege environment. From evaluating policies to identifying unused permissions and enforcing compliance, IAM security tools are essential for maintaining tight, controlled access in modern cloud environments. The IAM Credentials Report is a powerful security-focused tool that provides a comprehensive snapshot of all IAM users within your AWS account. It's designed to help administrators quickly assess the health and security posture of user credentials across the environment. The IAM Credentials Report provides rich details that are essential for managing account security. It shows whether each user has a password set and when that password or access key was last used, giving you visibility into inactive or stale credentials. It also reveals whether multi-factor authentication, MFA, is enabled for each user, helping ensure that strong authentication practices are in place. Additionally, the report includes information about the age and usage of access keys, allowing you to spot outdated or unused keys that could pose a security risk. Finally, it highlights whether users comply with your account's password policy, making it easier to enforce organizational standards and security best practices. By regularly reviewing the IAM Credentials Report, you can proactively manage access hygiene and enforce security best practices before vulnerabilities turn into incidents. The IAM Access Advisor is a built-in AWS security tool that empowers administrators with deeper visibility into how IAM entities, users, groups, and roles actually interact with AWS services. Rather than just looking at what permissions are assigned, Access Advisor shows what's truly being used, giving you a data-driven way to right-size permissions. For each IAM user, group, or role, Access Advisor lists all the AWS services they're permitted to access, along with the last access timestamp for each service. By identifying and pruning unused permissions, Access Advisor helps you enforce the principle of least privilege, which is central to a secure and well-architected environment. IAM Access Advisor turns permissions management from a static process into an intelligent, audit-informed strategy for securing your AWS environment. The IAM Access Analyzer is a powerful security tool designed to help you uncover and remediate overly permissive access policies before they become security liabilities. It works by analyzing policies attached to your AWS resources and identifying who can access them, especially when that access extends outside your account, whether to another AWS account, an AWS organization, or even the public internet. This kind of visibility is crucial for preventing unintended data exposure. For example, if an S3 bucket policy or IAM role unintentionally allows external access, IAM Access Analyzer will flag it, giving you a clear, actionable insight into what resource is affected, who can access it, and through what permission. The analyzer supports a wide range of services, including S3 buckets, IAM roles, Lambda functions, KMS keys, and more. It runs continuously in the background, automatically generating findings anytime a policy change introduces potential risk. These findings are clearly surfaced through the IAM console and are also accessible via the AWS CLI or SDK, enabling integration with automated workflows and security dashboards. With IAM Access Analyzer, administrators gain a proactive layer of defense in real time, and across the entire AWS account, playing a vital role in implementing a zero-trust security model. Thank you for joining us in this video. If you haven't already, we'd love for you to subscribe to our channel to stay updated with our latest content. We look forward to sharing more insights with you in another video. Until then, keep exploring. And thank you for watching.